Okay, let's do a vector practice problem. So for these two practice problems that you just saw on the screen, there's an airplane that is traveling at 110 kilometers per hour, and it's moving upward at an angle of 25 degrees to the ground. So I'm going to draw a picture of that right here. So here's the dot. This is the airplane. So the airplane is moving in this direction with a velocity of 110 kilometers per hour. So I'm going to draw in the ground over here, and I'm going to make the ground the x-axis. This angle is 25 degrees, and I'm going to also draw in my y-axis. Now, for problem number 1, it's asking how fast would a truck or a car need to travel to stay directly underneath this plane that's traveling at 110 kilometers per hour at this angle to the ground. So what we need to do then is we need to take our vector, the velocity vector, and we need to resolve it into its components. If I draw in a perpendicular line here, I can draw in the x component right here. So we need to figure out for part number 1, what is that x component equal to? Well, if I take a look at this triangle, I've got Vx, which is an adjacent side, and I've got V, which is the opposite side. So that would be the cosine function. So cosine of my angle is adjacent over hypotenuse. So let's rewrite this for our particular problem. So the cosine of the angle is going to be equal to, the adjacent is Vx, and the hypotenuse is V. So if I solve this for Vx, I get V cosine of my angle. So this is the equation to solve for number 1. Let's put the numbers in. So Vx equals, we've got 110 kilometers per hour times the cosine of 25 degrees. So this is a little bit tricky. We get our 99.69 for this. However, if we look at the information that's given, I've got 2 sig figs here and 2 sig figs here. This would round to 100, but of course 100 only has 1 sig fig. So the best way of writing this one is 1.0 times 10 to the 2 kilometers per hour. So this, actually what I'm going to do is I'll write Vx for the final answer here. So this truck or car would need to travel 100 kilometers per hour to stay directly underneath this plane. It's about 62 miles per hour. The second question is, how fast would a helicopter have to go to maintain the same altitude as the plane as it's lifting off the ground? So for that one, what we'll do is we'll add in another perpendicular line, but this time it goes to the y-axis, and I write Vy over here. Now the nice thing about vectors is that you can pick them up and you can move them wherever you need them to be. So this Vy vector, I'm just going to move over here to complete the triangle. So this side right here is also the same as Vy. So how do I find what Vy is equal to? Well, if I didn't have Vx, I'm going to sort of ignore that right now, then Vy and V make up 2 sides to the triangle. They make up the opposite side and the hypotenuse. That would be the sine function. So sine of my angle would be opposite over hypotenuse. So for this problem, the sine of my angle, opposite would be Vy, hypotenuse is V. So Vy would equal V sine theta. This is the equation that solves number 2. Now let's put the numbers in for this. I'm going to put it over here just because it's getting a little bit low. We've got 110 kilometers per hour times the sine of 25 degrees. And this will give us 46 kilometers per hour. And this one has the correct amount of sig figs. So this is the actual answer. So the 46 kilometers per hour, that's the vertical speed that would be needed for the helicopter to maintain the same altitude. And the 100 kilometers per hour is how fast you would have to go to stay directly underneath the airplane as it's traveling at 110 kilometers per hour at 25 degrees to the ground. So here's a sample problem of how you do vectors. I'll see you in class.